What the hell is an AI agent?
The smallest atomic unit of something that can give you an autonomous answer. If you're feeling really brave, you can have the LLM automatically create the text message and send it for you. Humans do this when they dream. You resolve your memories of the day when you're dreaming. But what you're really doing is understanding what's important and not important. Claude is a great example of something that checks what it's doing. Not just at the prompt level, but behind the scenes. And a lot of people are afraid, oh, this is going to take over the world. It's not.
So what I did today was to bring 2/3 of the co-founder team at Eidolon AI. I've got Ravi, Ramachandran, Dave Brewster. How are you doing today?
Very good.
Awesome. Where are you hauling from?
I'm based in California in San Jose.
Yeah, and I'm in Ohio.
That's pretty sweet. Let's jump straight into that. What the hell is an AI agent?
Sure, absolutely. So the definition's a little bit all over the board, but all I can do is tell you how we define it. I think agents come in various sized packages, right? So you see some of these larger agents trying to code for you or trying to debug your code for you, things like that. Those are obviously very large agents, very complex agents. And you see something simple, a tool that will automatically allow you to search your docs on S3 or something like that. Both of those to us are an agent. In fact, we define an agent as the smallest atomic unit of something that can give you an autonomous answer. So an agent to us is a simple service. Some of those larger complex agents that I mentioned, those typically are made up of many different services under the covers, many different calls, many different contexts talking to an LLM, but all of those to us still are agents, right? Autonomy, I think, is the key word. Something that can give you an answer from an LLM is an autonomous agent for us.
Okay, so let's address the elephant in the room immediately here. Let's say I've got an agent and it can do things for me. But I've also spoken to ChatGPT, and I know that even though it does great things most of the time, it also sometimes just makes things up and does completely bad thing. What is it useful for today? What's at the point where I can actually deploy it and it's autonomous?
Yeah, I think if you look at some of the really nice agents that are built out there, they have fault tolerance built into them, what I would call fault tolerance, right? To the point where a lot of them will double check answers. A lot of them will double check what's going on. For example, if you use Claude, right? Claude is a great example of something that checks what it's doing. Not just at the prompt level, but behind the scenes. Everything with Claude, you can tell when you use it, is made up of multiple LLM calls, not just one. And one of the things they're doing in the background is firing off multiple requests and getting two different answers. Or if you ask for something on how to code, they're firing off another LLM request in order to pull that off. A lot of times people call them tools, right? They'd be tool calls. Sometimes you can do it ahead of time and sequentially branch the call and then resolve on the back end. There are many different mechanisms to check to see if something is working well. But the very simplest, the very easiest GPT 3.5 question we would ask in the past was one call, right? It was one call without any checks. And I think that simplicity at the agent framework level is going to go bye-bye, right? If you're producing something that is useful, it can't be a single simple agent call that gives you one answer. It's got to have checks and balances built into it. You have to have the ability to call off onto other agents or tools in order to do work for you, et cetera, et cetera, et cetera. There's lots of techniques to avoid hallucination that's out there. But for us, from an agent framework point of view, having that checks be agentic in itself, it was really what we feel like is the way to go.
So would you say that the biggest limitation really at the moment is this trust and everything, that works to...
Yeah, it is. But trust comes at a lot of levels, right? Trust at an enterprise comes at many levels, not just trusting the answers you get, but also trusting that your data is not getting to get copied and released somewhere else. It's being able to understand the lineage of where all the requests, right? So governance built in to the framework that you're using. So if a user makes a request, knowing what agents that touched, what data they had access to, how it was touched, et cetera, et cetera, et cetera, is is one of the things that enterprise would consider trust.
Part of it is the market maturity. And right, once things are in early stages of an evolution in a new market, it's just natural apprehension to make sure that things are fully baked and can be brought to market. So I think the part of that trust issue is security. There's the aspect of, where's my data? Where are the skills in an enterprise to roll these things out? Where's the infrastructure at? And then how mature are the people and vendors that are offering the market and the technology in this space? So it's a market maturity that then drives a lot of the trust factors that they've just mentioned.
Where I'm sitting as a software engineer, one of the things that comes to me the least naturally with this LLM technology is the fact that the visibility, observability of it is a little limited. And by little, quite. Most of the time, I don't know why it went wrong. So I get the argument that you can do redundancy and maybe launch multiple requests and maybe do some kind of vote consensus and pick the one direction that goes with it. But is that a problem that can actually be solved, or is that just something that we're going to have to get used to it?
I think observability is quite an interesting problem, right? If there's observability within a single LLM, that's hard. Knowing where that data came from that answered that question and why it happened. I think Gen AI researchers struggle with why answers are even given, right? The whole concept of what is really going on. And I know it's a pick next word game, but why did it pick that word from a vector point of view, from all of these things? Like some of that, I think, is not really known well. But observability on where my answer came from with respect at the LLM level is quite possible, right? Again, today, the way that a lot of people think of LLM calls is as a single call. And those days are really going to be numbered. So if you can observe not only the LLM made this response, but what data did it have to make that response? What tools did it have access to that it chose to call or not call? And if it did choose to call them, what did it ask them? Things like that. That is super important for a software developer to be able to understand. But within an LLM, I don't know of any good research that's available. That's a really difficult problem inside. Maybe OpenAI, maybe Meta, Anthropic, maybe some of the other vendors can figure this out, but observability should come or needs to come at the tool level as well. And it's really not there either today.
So we've got some of the problems here, and you guys are obviously heavily invested in the AI agent thing. So what angle do you attack it at Eidolon? What's your unique selling point?
I think we've come at it very much from a perspective of people are building agents. Again, what can people consider agents varies. And really a lot of the focus has been how do you end up building these things, and less so about how they're really deployed. And we've seen the big problem being these agents never seem to make it to the end into production. And really thinking about that problem as a very key part of an agent framework, but also an agent server is how is it going to get deployed? How do these services communicate? How do they coexist in an existing environment where there's many other services, many other applications running? So not just simply building, but also making sure that can be easily deployed. And that's one of the key thoughts that we focus on, and why we call it an AI agent server is one of the key ideas of production workloads that can be deployed and thinking about that up from the ground up, right? And that's one of the key things that we think differentiates us.
That I think that is the biggest one. If you look at a lot of other frameworks, they focus on just the framework part. And if you want things like observability built in, and if you want any kind of auditing built in and things like that, you can do that as just writing files or hooking into something else. But really the way that the industry is seen from a software developer point of view is to turn those into services and turn the thing that runs them into a server that monitors and gives access to all of that information for the end user that's running it. We've chosen an easier way to do that by plugging into Kubernetes, right? So for large scale deployments of our services, you install a K8s operator and we're custom resources running on the Kubernetes clusters. That makes us super easy to install, super easy to deploy the agents, changes to the agent, et cetera, et cetera, et cetera. And we can leverage everything that Kubernetes gives you related to that DNS and a lot of other things to be able to find the agent machines that are running in a clustered environment, which allows you then to have multiple agent machines running in one cluster that gives you the ability to have different RBAC rules associated with each agent that's running in each one of those servers, or even at the whole agent machine level, really clamp down the security. If that machine might have access to an S3 buckets that only the CEO of a company should see, you could lock down that whole agent virtual machine concept so that only that process, only that node, only that machine, however you want to deploy it, has access to that data. So the whole concept of an AI agent server really brings those ideas together in a way that makes it simple to manage and monitor and meter your agent deployments.
Got it. So you build up on top of Kubernetes and you provide this glue that makes it easy to deploy these things and put the right bumpers around that. And in terms of the actual agent technology, whatever is making the external API calls or effectuating these changes, is that your open source stuff doing that?
That's right, Miko. There's two parts. There's the agent server and the agent SDK.
Yeah.
And so the SDK is the open source project that's there. And the Kubernetes operator is open source too. It's all there together. But that is what you code against. And it's interesting, for a lot of things in our SDK, we believe, as I said earlier, that an agent is an atomic unit, but it's also a collection of agents that build something more complex. So what you'll see when you download and get our SDK is a bunch of pre-built agents built in, and they allow you to simply assemble them together to make something more complex. I'll give you an example of that. We have an API agent built in that is an autonomous API agent. You point it at config time to an open API JSON file, a Swagger JSON file, and it will learn what APIs are available, what the endpoints are, and how you call them. There is also a RAG agent that's there, which you can plug different loaders into. And a RAG agent, for people that don't know, is what you use to process a large number of documents that won't fit in the context. And putting those two together with a GitHub loader, you can very easily, like just a few files of config, create something that lets you search your docs, monitor your issues of GitHub, et cetera, for changes, so that when you're creating a pull request, for example, you can ask the API endpoint, what should I put in this PR? What should the description be? And voila, you would get an LLM guided response that matches your code, from the ability to search your code, the ability to search your docs, and matches the changes related to the files that are in there straight from the LLM that you can copy paste or put into your GitHub pull requests. Built of smaller agents that are available, let you assemble things that are there. We really believe in this Lego building block approach. And if we don't provide the agents that you want, the SDK is also code, so that you can write code for your own agents, for your own building blocks to put things and build things together. Every part of the SDK is completely pluggable. Everything's behind an interface that makes it very easy to swap out a different implementation for.
So that makes sense to me, but I'm still wondering, so between the LLM that produces some text and an action actually happening, is there like a standardized interface that describes actions that it's supposed to spit out? Is that how it works?
You have an agent, and to us, an agent's a service. So every agent needs an input that can be described by JSON schema and output that can be described by JSON schema. Input obviously is much more important than output here for our use cases. If that agent wants to talk to an LLM, we do it through this concept that we created called an agent processing unit. And an agent processing unit takes care of all communication with the LLM, not just at the simplistic LLM level, but also everything related to memories, tool calls, any kind of IO transformation, storing things on the local file system that you need that are temporary, et cetera, such that when you're coding against the LLM, it really just feels like another API endpoint that you're calling. And given the fact that you can describe the input and output schema of what you give to the LLM and how you want it formatted back, it really allows us in many different environments to tailor that to the output that you get. So for example, say that you're using a model that doesn't support tool calling out of the box. Our IPU will wrap that call in something that will pull out and discern the JSON that's there and treat it as a tool call, right? We'll do all the heavy lifting to put all of the prompting in there that's needed, everything that's needed in order to fake tool calls, if you will, which does include multiple LLM route trips, and call the tools, get the responses, give them back to the LLM, et cetera, in the loop until the response comes back. I'll give you another example. Many models don't support images, right? So image to text, I'll use that as an example. The APU has an optional component you can register on it that will do any image to text translations automatically for you, and vice versa, and speech to text, audio to text, and the corollary of that as well. So that all you need to do is register a more complex APU where you give it the base LLM and you give it an image converter or image processor and an audio processor optionally, and it will make all that work automatically for you. The APU also handles document upload RAG as well, both in context and search, just like Claude and ChatGPT do as well. So the APU really is there to abstract away the complexities of the LLM, not just at the simple LLM call level, but the whole thing, tool calling, image translation, et cetera, for you. You can have multiple APUs in an agent. The only use case for that is if you have a chatbot interface where you want to switch between different APUs dynamically, but you can if you're doing something really complex in an agent. And again, it's just a separable component that can be plugged in like anything else.
Got it. So let's walk through a use case that's currently brewing in my brain. If I go and check out your stuff, will I be able to implement an agent that can look at my Slack history of the day and order me the right kind of coffee, depending on how bad the day is, maybe a double or a triple, estimate how long I'm going to take and how late I'm going to be from work and text my wife? Or would I need anything custom for that now?
Yeah, we don't have a Slack loader, so you would need that. And we don't have the ability to text, so you would need that. But everything else in the middle, probably not. Like
I'll just plug in Twilio or whatever.
Yeah, exactly. We haven't built the Twilio integration yet. Yeah, it's not difficult. And like I said, everything is component-based. Yeah.
There you go.
You can have it autonomously happen where you register the text your wife as a tool. If you're feeling really brave, you can have the LLM automatically create the text message and send it for you. There you go. Without your approval. I'm not sure I would do that, but
I think Miko's on the right track in the sense of we're already seeing things that are going to be done very differently, right? From a personal point of view, how you live your life, how you do your day-to-day tasks, get your coffee, get whatever your favorite beverage or your restaurant meal is. Those things are happening today and just accelerate. Of course, if you have the right kind of tools that you give the LLM to give the agent to be able to access, a lot of different things are possible. So for sure.
Yeah. And obviously, I'm hoping that Tim Ferriss is watching this and he's proud for the 4-hour work week here, saving all this time. But on a more serious note, I think that would actually be pretty cool if I could have something that like reads my emails overnight and preps the morning for me with a summary of important stuff and the stuff that I need to tackle. I would pay money for that right away. But I wanted to go back to pick a little bit on your sales pitch, Ravi. You mentioned that if you looked at how things are being deployed today, they basically aren't. They never go into production. If I had like a magic wand that would tell me what everybody's doing with AI agents in general, where would they be? What would they be doing? And what percentage would you estimate actually makes it into production use?
Oh, wow. Look, I think today we're seeing a lot of POCs and a lot of the effort has been around showing the art of the possible, right? So pilots, POCs, and they can be across different functions. It could be in a particular domain. And I think there's been a lot of interest because there's a top-down mandate for people to be able to use and test agents and actually show what's possible. That's more from an enterprise perspective. I think from a personal perspective, a lot of this is around personal productivity. You mentioned things like automating your calendar, reading your email, responding automatically to things that are today just tedious for people to handle on a day-to-day basis. Those are, I think, the two different worlds. I think the former, which is doing things, giving access to a web browser, to your calendar, again, trust notwithstanding, those are very much already in motion. I'd say much probably ahead of more of an enterprise use case where those things are much more in the POC pilot stages that are moving towards production, I think, over the next 12 to 18 months. But yeah, that's the state of play as we see it. So are there production deployments? Yes. They're nearly as many as they should be. No. And that's a big change that we're going to affect. And we're trying to think about it from the end state, not just from the out of the possible.
Do you have any funny stories on that subject? I know there's a lot of stories about chatbots going wrong, starting to insult clients and telling them the wrong things. Are there any cautionary tales for, obviously, why people should use your stuff instead of doing it badly?
Yeah. The biggest funny story I have is I think every developer that does Gen AI runs into this once, hopefully not more than once. You start a process that is running to discover whatever, to do RAG, or I think for me particularly, I was loading a schema and trying to do a hierarchical graph representation of the schema. And you start it, you code it, you program it, you run it, you debug it, you run it, you debug it, you run it. And it's late at night, it's 1 a.m., you run it, and it's not producing the results you want, you're frustrated, you go to bed. And you didn't stop it. And it runs overnight, runs into the morning, and you wake up to 50 emails of your account has been funded from OpenAI with more money. And then voila, there you go. That's my cautionary email, like to developers getting into Gen AI. If you create an agent system that can recursively call itself, it will, and it will rack up some dollars real quick on you.
And that won't be funny.
Yeah, it's not very funny. Yeah. But that's the biggest one that I've personally run into. Yeah. Or boring, redo enterprise stuff.
Yeah, my brain is just like searching through the images and the memes I've seen over the years of all the things tons. About leaving a credit card in your cloud account and accidentally leaving an instance when you went on a holiday. It's a real thing.
Multiply that by 1,000 with LLMs. Yeah.
It's very interesting, right? I think the cost aspect of it is something that people maybe don't talk about as much, which is what Dave's mentioning. And I think in general, the agents, you talk about the productivity aspects of it, and there's been a lot of discussion on how productive it makes all of us. There's a cost aspect of it, which is making sure that's done in a responsible way and a fiscally responsible way. But there's also, I think, the creative aspect of it. If you just think about how agents are literally changing everything that we do, it just gives a lot more freedom of people to be able to not focus on the lower level tasks, but really get much more creative about thinking about problem solving. And that's not something that we talk a lot about too. I think that's one very, very specifically a benefit of AI and agents, which is letting people's mind be open, letting them create and really be able to express themselves in software and other aspects of life, which I think is really pretty cool. I don't know how you'd measure that, but hey, not everything needs to be measured in that sense.
And your stuff specifically, do you have any cool use cases you can share of people using it to do cool stuff at the moment? Actual, production usage?
So you start with the simple, right? One of the things I find interesting that people are doing is using it as an API gateway, right? As developers of business apps, one of the things that is the most boring and some of the hardest, by the way, is you're writing a service that needs to call a bunch of different API endpoints and coding to a doc that likely wasn't updated anytime recently. And that doc is incorrect and it doesn't adequately represent what you need to do. But when you hit the endpoint and you look at the docs on the endpoint, they're right, they're there. A developer, while they were editing the code, of course, edited all of the open API stuff that's related right next to it, if you're using a reasonable framework, and everything's up to date, everything's there. Super frustrating. So one of the cooler, smaller things that I've seen people do and put in production is using an LLM as an API gateway. So you have your code call into an agent. Again, it's just a service call in our framework. And that service call is your own personally fixed endpoint, right? Like it has this JSON schema that you want it to have. You're going to call it from code. It's never going to change. It's what you need it to be. But that then calls into a remote service and you let the LLM make that call. So you load the Open API schema into the LLM, either using RAG or directly in context. And then you let the LLM give you back a tool call that would be the remote call. You make that remote call. That's a really interesting use case for lots of things. In particular, what this guy was using it for is to call into multiple states, have basically the same endpoint for regulatory stuff. And they semantically have the same input, but syntactically they're completely different. And you need to file a document with each state. They're using it like that, right? So call into this one, et cetera, have an LLM do it autonomously. That's like a simple, really cool use case. Something more complex is in a claim system, right? You're an insurance company. Say you're an auto insurance company, right? You write policies for auto insurance, and a claim comes in. And one of the first things that an insurance company does is determine, is this a fraudulent claim or not a fraudulent claim? And historically, that's been done completely by humans. I think historically they did it all as a statistical exercise. But later on, as computers got more and more involved, it involved rule triggers. And even today, the state of the art pretty much is rule triggers at most insurance companies. They're starting to use to detect that as well. But LLMs are much better at doing that than standard machine learning models for one reason. And that's a lot of the time, the things in the claim are written in the notes. Like 90% is written in notes, or it's an image or a series of images or whatever. And using standard machine learning to do that, while it's great and possible, it pales in comparison to using an LLM to do that because of its natural language abilities. Using it as a Bloom filter for insurance companies on claims is something that is extremely cool. And then I think if we start thinking about the future, which is a little bit of a segue of where do we go from here? What's the next big major milestones in LLM? We then would start talking about memory and adding in-context memory to what's going on.
I like the segue, so let's do that. Let's say that we solved a memory problem. How does the future of humanity change?
Yeah, exactly. Wow, it's dramatic. Big dramatic question. I think a problem we have with LLM toolkits today, I'll start there, is that they're bare metal. So if I'm using LangChain and I'm trying to code up my app, it feels like everything I do is different. The way I approach the problem is different. To me, I would call that like a bare metal implementation. To give a good example, I started my career many years ago at a company called NetDynamics, which is an app server company. And just Fast API or whatever you use today, those roots came from one of this company or a couple other companies. And when we were developing the first app server, people were using what I would consider very similar to the calls that they do for OpenAI today or any bare LLM call, in that they're just very low level, they're very direct operating system, and they're not higher order packages. So if I'm using an app server today and I want to, I don't know, forward my call and code to something else, it's one API call. It's super easy. Or if I want to return a JSON package on my response, it's super easy to do. And I'm still being pretty bare metal-ish here. But as we've developed the app server over the last 20 years, or even more, the packages that are available to you to do that have gotten larger and larger and do more and more for you. The LLM, where we're at today with the SDKs that talk to an LLM, is they're still very bare metal. And I would also include Eidolon somewhat into that, right? Like our goal is to up level the API so that you're working with these larger level Lego blocks instead of having to implement RAG yourself or think about it at a low level and make those decision trade-offs between, do you want to do multi-query, single query, et cetera, et cetera, et cetera, et cetera for that. Memory is, to me, the breaking point where simple versus complex, being able to do bare metal, and then having to use something of a toolkit that takes care of a lot of things for you. Memory will be that breaking point, in my opinion. Why is that? When you introduce in-context learning into a series of agent calls, you change the way the agent is working dynamically over time, right? So let's start real simple. I have a chatbot, and that chatbot remembers me as a user personally and what I like to talk about or what's there, et cetera, et cetera, et cetera. That's pretty simple and can be coded, right? But you got to make some pretty big decisions on what's important, what's not important, what's the context of what's there. How do I roll that context in over time? I could tell you the sky was blue today and now it's tomorrow. Is that an important memory? Probably not. It might be, but probably not. I tell you my name, that likely is an important memory. If I tell you that the sky was blue today, what is it tomorrow? And I'm a weather person and I'm really into weather, maybe the sky being blue means it's clear and it is more important. So how do you work context into that? Now let's bring that back into my agentic use case where it's not a simple chatbot remembering memories, it's an agent over time. And let's bring that back to the claims example. I've written a series of agents that determine if a claim is important to this company or not and should be litigated. And there is one particular trigger me as an insurance company finds fraudulent. I could make one up, but I'm not going to. If you tell that agent over and over again that no, that claim was fraudulent, either through reinforcement learning or lots of other techniques, then that system, if it remembers that claim being fraudulent, can then have a higher accuracy over time. How do you do that in a very simple bare bones system without writing a ton of code? It's pretty difficult. We don't have long-term memory yet in Eidolon, but it's in a pull request and it will be here very soon. But those are the things that we're starting to think about. How will memory affect what you're doing over time? And then once you add memory, how do I resolve those memories over time in order to allow reinforcement learning again or some other system to bring the important memories up and push down the unimportant memories, right? Humans do this when they dream. You resolve your memories of the day when you're dreaming. But what you're really doing is understanding what's important and not important and a lot of other emotional things that hopefully we don't have to worry about with LLMs. But you do build a level of importance for your psyche during that time. So how do we do that? What does that mean in an agentic system? Not only at the user level, but the agent level. What about the agent-user combination level? Should an agent remember some things globally, but other things per user? This is all going to lead to a lot of code and a lot of logic, where if you're not working in a system that handles that for you, me as a coder, that's a lot of code. That's going to be a lot of work to do in a one-off case all the time. That's a little bit, I think, of where we're going and what's coming on and how memories will affect agents.
The memory, the way that people would think about it, like the stuff we describe with humans, where we remember the right things and then we can recall and it all just works out. That's science fiction today, right?
There's a lot of research people playing with it. The seminal paper that happened quite some time ago was a research paper out of, I believe, Stanford, where the guy basically created a version of The Sims, like the old classic computer games, The Sims, using ChatGPT 3. I don't even think it was 3.5. I think it was 3. And he added memory to that. And that kind of led a lot of people, including myself, to really start thinking about it over a year ago. Yeah, way back in the LLM days of over a year ago. But there's this thing called MemGPT that came out quite a while ago. And now Mem0, which is a rev on it. I don't think it's science fiction. I think it's still at the research level, still at the top of people's brains. But it's honestly not a difficult thing to do. What's difficult is understanding contextually what's important and not, but that's what LLMs can do that. So it's just a multi-cycle LLM loop. You store the memories as RAG and documents in a vector store. And the important part is what is the supporting data of the memory and what's the memory itself? That's the thing that Mem0 finally got right. Like the prompt in order to generate the things that are useful for a prompt in the future. Sounds confusing, but that's what they got right. But it's not, I wouldn't say science fiction. I would say it's going to be a huge rage over the next three to 6 months. Huge. You're going to start hearing a lot about in-context learning, memories for LLMs. You're going to start seeing it in Claude, and you're going to start seeing it in ChatGPT for sure. It may already be in Claude. There are some things that I've searched recently that let me believe, if you've used Claude, a project in Claude is the memory boundary for the user. Start a new project, you get a new memory. context. I don't know if that's true. I could just be making that up. Sorry,
We'll look
interrupt
it up.
people if I'm just making
We'll
this up.
fact check you a bit later. Okay. What else would be a major breakthrough other than the memory? What's next on your list?
I think that's one of the hard parts for anyone using an LLM. It seems so science fiction-y. What can I imagine I can do next? So a problem with an LLM, right? It's a learning model. It's a model that has learned. It did learn and is not learning anymore. LLM calls are stateless. So by adding memory and learning over time, preferences of either a system, a human, or even a subject matter, and then storing those memories off, will lead to major breakthroughs. Like for example, everyone talks about RAG score. So this is something I want to try. But what if you learn the series of concepts that are in the documents you're processing so that you can learn the semantic hierarchy of the documents that are there, the ontology of the documents that are there. And then when questions are asked, you can give that ontology to an LLM. I think you would get a much higher RAG recall score on that. But that's a very tactical thing, right? Like memory will tactically change how people approach problems because you can create systems that learn in the environment that they're deployed in versus in a lab somewhere. That will lead to smart assistants at home, I think, for the everyday person. That will lead to, like, I hate using the word robots, but systems that will learn your behaviors and what you do. We do the same things every day. Our tendencies are very strong, and it wouldn't take very long for something to learn that. Whether people wanted to or not, it wouldn't take very long. So I think what you were saying, writing emails for you, sending text messages at the appropriate time, paying attention to the environment around the human host. Wow, I'm going to start getting creepy here. Around the human host is an easy thing for LLMs to do if they have memory associated with them. So I think you're going to see those tools a lot. But in the enterprise, learning your vulnerabilities at a security level, at a CISO level, it's not going to be very difficult. That might be expensive, but it wouldn't be as very difficult. Like I said, that the RAG use case is a very common use case, and the problem with it is the recall scores are bad as you move context around. But that could change. Learning the behavior of an employee or multiple employees over time by a system from a security point of view is also something that can happen. Again, whether good or bad, like how we use this is more important than what's getting created, right? So memory adds a whole new level and a whole new dimension to what's going on. And in past that, I personally have a hard time grokking what is next. Like a lot of people. What can this thing do? I don't know. I'm a coder. I tell the computer to do something and it does it. But when it's acting autonomously, it's like, how do you assemble a human brain so that it's useful? In my mind, that's the way I think of it. So.
Oh, wow. A lot of scientists would be very upset about you comparing a human brain to it and argue that it's nothing alike.
I know they would, but we won't get the same results, but we're trying to mimic, right? So let's think about how the right way to mimic.
Dave, why do you hate robots?
I guess my desire to have independence without being independent. How about that? That's a great question. I don't like using that word because I don't like using words that compare LLMs and agents to human behavior because it's not the same thing. And a lot of people are afraid, oh, this is going to take over the world. This is going to do that. It's not. Like, that's not the way it is. But if it's about information gathering and information sneaking and learning things maybe you shouldn't learn, they're very good at it. And that concerns me that I live in the Midwest. I lived in the Bay Area for 30 years. The level of employee autonomy in the Bay Area versus here are two radically different things. You work for a company here in the tech industry, but if you're in a manufacturing warehouse, they know what you're doing all day long. They monitor your email. They monitor where your packets you send. They do everything, like for good or bad, right? It's to protect themselves, but they do it. Unfortunately, I think people use that for bad reasons. LLMs will allow them to do that ubiquitously across what the employee does, where their mouse clicks, how often their mouse moves. If somebody wanted to code that program up, that series of agents up, they easily could. So then when you move that into the realm of a robot and you take that level of independence away from somebody and have something monitor. I just don't want people to get this dystopian view of the world of robots will attack and kill us, because that's not the way it's going to be. But then you see information gathering and information snooping on people, that very easily could be the way. So that's why it causes me that internal struggle.
Oh, wow. I didn't expect it to go this way. I thought we were going to talk about
to go this deep.
The Unitree robots. I was having a proper think about it. Once I realized, okay, fine. So you can actually buy this now. It's like a small humanoid robot that's supposed to be able to carry things around and bring you a beer, finally. And it no longer costs 100 grand. I think it costs like 16,000 now, which means they'll probably drop in price a few years now.
Yeah, I don't mind getting the beer myself. I want to do the dishes to be done. That would be really awesome.
There you go.
So I'll go with the beer. I'm good with the beer.
Because, the robots are sneaking into my house anyway. Like my vacuum cleaner now has a voice recognition feature that I didn't ask for and disabled, and I hope it's disabled. It's walking around vacuuming. It's got like a little lighter in it. I hope this is only what it's using it for. So I guess got past the fact that there is like an autonomous thing that will hopefully not murder me in my sleep.
There you go. Hey, I have an autonomous idea for an autonomous agent that somebody could write. Something that monitors your web presence and the packets going out of your house to see who is snooping on you. How about that one?
There you
Fight
go.
fire with fire. Anyone wants to create that one, I'll help to work on it with them. How about that? Yeah,
the good guy, the good hacker. Where are you taking that? So you said this is still pretty close to bare metal. You're hoping to up the game. What's the end goal here? What do you want to do with it?
I think there's the boring parts, which is adding more connectors to more systems and blah, 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 blah. That's always going to happen. I mentioned memory. We're adding long-term memory next. We'll add memory consolidation in the future. That's going to take some time to get right. We'll integrate memory into all the other existing agent types. That's going to get right. Of course, we're monitoring all the papers that are out there, and we will implement what's needed there. One thing that we won't do is what some of the other frameworks do and add implementations of every little fad that exists. That as a developer using those toolkits, wow, that is so annoying. Of command completion brings something up and fad of the day shows up. That is so annoying. So from an Eidolon SDK point of view, it will be adding more of those building blocks as things get larger. We have RAG right now. We will add different kinds of RAG. We'll add RAG for different contexts that are very specific. We have text to SQL. We will continue to enhance that. We have an API agent that, like I said, calls autonomously into any API. We'll probably add a series of agents on top of that for existing systems that are out there. That, again, just adds context to the prompt and things like that. We might, one potential thing that we're discussing internally, right now it's Python only, but the ability to add an agent for any language that's out there. Since it's modularly built, component-based built, we can stand up an API for any kind of surface area of components, if you will, and then allow you to code agents in Java or agents in Go or whatever you want pretty easily. It's just us creating a facade for all of those APIs that we have available, or the right surface area, like I said. So those are some of the things on the open source project. But Ravi, do you want to go into, as we transition the parent company, August Data, into an enterprise company, Eidolon will stay 100% open source, guaranteed. But maybe, Ravi, you want to talk about some of those?
You covered the product piece of it. I think if you just take a step back, we're building a company, a project and company to make sure that everyone has access to AI. I think broadly speaking, if you think about the mission of the company, which is to make sure that AI is not just for the few, which is a type of language program or a type of role in your company or an individual, right? You should be able to access that broadly. And I think that's an overarching goal. And the other piece of it is really build a very open company. So not just the open source and the licenses that we actually build software on, make it available, but ensure that we can get the inputs of a wide variety of people, both who are in the company today, which is a handful, but also the community as well. And so just one example of that is that the way we run the company is very much open public. We have daily stand, which is different from office hours. We actually have stand-ups where anyone can join our stand-ups any day. So Miko, you're more than welcome to sit in our stand-ups and see both how we're building the product, what's working in the company, what's not, how we tackle issues. So it's very open and very embracing the community at large. That's one of the reasons why we got together to start the company, because we very much had the shared vision of opening and doing something that's bigger than us ourselves. So I'd say that's more philosophy and where we're taking the company. Dave described the open source projects. Clearly, we're building a product for the enterprise, so individual developers today, but also taking it to the enterprise, because that's been our background. And one of the things you mentioned earlier, Miko, is what makes us different. And we touched a little bit about the technology aspects of it. You know, a lot of this comes down to teams of people, and it's really all about the people that are building these technologies, especially since they're new. And having a background in building this for the enterprise is really what we've done. And I feel like that's super critical to eventually being successful. So the technology is great. What do you do with it? How do you think about problems? And that comes from experience. So that's really super important to us. Anyway, that's a smattering of things. I don't know if it all made sense, but hopefully you could put together the product vision with the vision of the company and see why we are different, not better. And I always think about that as, why are we different and what makes us unique, not necessarily what makes us better than other solutions there today, frameworks there today.
I think you forgot to mention how you're going to make humanity a multiplanetary species, and also how you're going to enhance human condition there. You might want to revise your pitch a little bit.
If you have us back, we'll make sure we cover that next time.
There you go. Dave, Ravi, it's been a pleasure to have you. Thank you for coming.
Thank you so much.
Thanks so much.
For having us.
Thank you.